Build quadratic models from verbal descriptions and from data. So this section talks about using quadratic functions to answer word problems or to talk about data. So let's just take a look at this first problem. It says, suppose that the price per unit in dollars of a cell phone production is modeled by P equals $45 minus 0.0125x, where x is in thousands of phones produced. So if x was 1, it would be 1,000. So that's what it means, thousands of phones produced. And the revenue represented by thousands of dollars is R equals X times P. Find the production level that will maximize revenue. So just be clear on what P is. It says, suppose that the price per unit in dollars of a cell phone production is modeled by this here. So P is our price. So find the production level that will maximize revenue. So we're just trying to find that production level. So what we're going to do here is we're going to take a look at this formula R equals XP. If you're not familiar with it, R means revenue. So I'll write this. So my R is revenue, which is the amount made. So let's say I had 10 cell phones and they were $100 each. The revenue would be $1,000. So that just kind of shows you that, okay, so it's the money made that's not your profit. Some people think of money made as profit, and it's not. This is just the total amount made by the product sold. That's what revenue is. Now, X is the number of phones produced in thousands. And that's what it says in here, in thousands. And then P is the price per unit in dollars. So I just want to write that all out for you so you can see everything together here. So now we have this formula here, P equals $45 minus 0.0125. And what we're trying to maximize, find the production level that will maximize the revenue. Now remember, X is the number that is the production level. So that's what we need to find. But we're trying to maximize revenue. So this is the formula we want to use because that's what we're going to maximize. So I'm just going to write R equals XP. Now, if we're going to use this production level, this X here, we're going to have to get this revenue in terms of only X. Now, the way to do that is because we have this P equals here. So what's going to happen here is we're just going to take this part here and replace it for P down here. So that's what we're going to do here. So our revenue is really X times, and I'm just going to write the 45. I'm taking the dollar amount out here because this is going to be a dollar amount. Not X, but R is 0.0125x. And I'm just putting that in place of the P. So now I'm going to multiply this out. So this is going to be 45, x minus 0.0125x squared. And now you can see why this was dealing with a quadratic function. Because notice this polynomial here. That is of degree 2. I have this x squared now. So that's why I'm dealing with a parabola. Now, one thing that's interesting about this, notice this parabola here. And I have a negative on the leading coefficient, which is the x squared term. And that is negative. So since it's negative, that means it opens downward. So if it opens downward, what am I going to have here? I'm going to have a maximum. Okay, and that's where this is all coming from. So if we think about it, how do we find a maximum? Well, if you think about the maximum this way, the maximum is the vertex, okay, because that's the highest it could go. So that's really what we're looking for in any of these problems when we're dealing with these maximizing or minimizing quadratic functions in these word problems. Because think about it, if it was a minimum, that means my A would be positive, my and meaning ax squared plus bx plus c. And that means it would be the lowest point then. So that would be a minimum if it was the other way. So that's the idea of these problems, any of them. I'm looking for the parabola, and really if I'm going to maximize or minimize, I'm looking for that vertex. So that's where we're heading to with this problem. We need to find the vertex of it. Now we have a handy dandy formula when we talk about the vertex. The vertex is x equals negative b over 2a. So really, this problem is that simple. It sounds really complicated, but honestly, it just comes down to, hey, let's find the vertex. So now that means, I wonder if I should rearrange this for you. I will, just in case you guys are having some issues with it. And I'll rewrite it. Let me rewrite it below. I'll do that. And I'm going to also write what A is, what B is, what C is, just so you have a clear understanding of what that means. There's my A. It's my multiplier of my x squared. They call it the coefficient. B is equal to 45, and my C is actually 0. And we don't need C, but I'm just putting it in there for the sake of putting it in there so that we have all of our A, B, and C accounted for. So now let's take a look at this one here. So the formula we're looking for is x equals negative b over 2a. That's going to give us the x value of our vertex. And that's where the maximum is going to happen at. And that being our production level. So that means x is going to be, let me fix that x. Looks like a ribbon. Negative 45 over 2 times negative 0.0125. And that's going to be 1,800. And all I did was punch that in my calculator. So that's all you really have to do for that. Now keep in mind, though, that if you're going to type it in your calculator as one computation, make sure you put the bottom in a bracket or parenthesis itself. So when you write it out, you write out the 45, negative 45, and then I'm going to do my divide symbol. And then make sure you use a parenthesis for that whole bottom to make sure you get the right answer here. So that would be my only hang up with using a calculator. Make sure you use it correctly. So it's 1,800. So that's where the maximum production level will maximize revenue, 1,800. And that X is 1,800 units. But keep in mind, it's not necessarily 1,800. It's not 1,800 because it says number of phones produced in thousands. So it's 1,000, 1,800 thousands. So think about what that means. That means it has 3 zeros, right? Because 1,000 has 3 zeros. So actually, if I was looking at the production level, would be 1,800 1,000s. So you're looking at 1.8 million. That's what we're really looking at. So I would say 1,800,000 phones. And that would be the maximum production level. That's the maximum revenue, excuse me. So what I'm looking at here also is, think about this. What if they ask for what is the maximum revenue? Then that would be the y value of my vertex, because my x value is the number of phones produced in thousands. The r would be a dollar amount. So I would actually have to plug in that x there, that 1.8 mil. But I wouldn't use the 1.8 mil. I would use 1,800 to actually plug it back in. I would use this number to plug it back in because this formula is already set up for thousands of phones per one x, for x being 1. So just keep that in mind. So this would be our answer for this one, though. We don't have to go any further than that. I just wanted to explain other questions that could go further. All right, so there you go.